So let's dive right into the exciting world of vacuum balloons, shall we? Now I know what you're thinking. Vacuum balloons? How does that even work? Well, stick around and you'll find out. The basic concept behind a vacuum balloon is pretty straightforward. It's all about the power of nothingness. Sounds a bit philosophical, doesn't it? But no, this isn't a philosophy class. It's all about physics. So we all know that a traditional balloon floats because the gas inside it is lighter than the air outside. This difference in density allows the balloon to float upwards. But what if, instead of filling a balloon with a lighter gas, you simply removed all the gas instead? That's the idea behind a vacuum balloon. In a vacuum balloon, all the air inside the balloon is sucked out, creating a vacuum. Because a vacuum is essentially nothing. It's lighter than any gas we could fill the balloon with, even helium. You might be thinking, but wouldn't the balloon just collapse in on itself? And that's where the science comes in. Theoretically, if the material of the balloon could withstand the pressure of the outside air without collapsing, then a vacuum balloon would float even better than a helium balloon. That's because the vacuum inside the balloon would create an even greater difference in density between the inside and the outside of the balloon, allowing it to float upwards. So, in essence, by filling a balloon with nothing, you could potentially create the best balloon of all. But of course, things are never quite that simple, are they? There are some principles of physics and some practical challenges we need to consider, but we'll get into those later. For now, just remember, a vacuum balloon is all about the power of nothingness. Pretty cool, huh? Now, let's delve a little deeper into the principles of physics that make the idea of a vacuum balloon possible. Specifically, we'll be looking at two key principles, buoyancy and pressure. So, first off, it's a principle we've all experienced. When you jump into a pool, you float, right? That's buoyancy in action. In simple terms, buoyancy is the force that allows objects to float in a fluid. And yes, air is considered a fluid in this context. Now, how does buoyancy relate to our vacuum balloon? Well, just like in our pool example, the balloon will float if the fluid around it, in this case air, is denser than what's inside it. And since a vacuum is basically the absence of anything that's less dense than the surrounding air, therefore, our vacuum balloon should float, in theory at least. But there's a catch. And that brings us to our second key principle, pressure. Pressure is the force exerted by a fluid on an object. In the case of our vacuum balloon, the pressure is exerted by the air outside the balloon. Now, if the balloon is filled with a vacuum, there's no counterpressure inside the balloon to balance it out. This imbalance could cause the balloon to collapse in on itself. So, while buoyancy is the force that could make our vacuum balloon float, pressure is the force that could potentially bring it down. These two principles, buoyancy and pressure, are like the yin and yang of the vacuum balloon. Both are necessary for the concept to work, but they also pose a significant challenge. We'll delve into these challenges and potential solutions a bit later. But for now, just remember, buoyancy and pressure, they're the key players in the world of vacuum balloons. Alright, now that we've got a basic understanding of the vacuum balloon concept and the principles of physics involved, let's look at how this could change our current understanding of flight. Currently, when we think about flight, we often think about airplanes that require tremendous amounts of fuel. Or perhaps we think about balloons that require lighter than air gases like helium. But imagine a world where we have vacuum. What could that mean for the future of flight? For one, vacuum balloons could revolutionize the way we think about air travel. If the vacuum is even lighter than helium, we could theoretically create balloons that can carry heavier payloads or that can float higher and longer. This could open up new possibilities for transportation, exploration, and even tourism. Imagine floating to the edge of space in a vacuum balloon. Moreover, vacuum balloons could also help us rethink how we use energy in flight. Traditional means of flight, like airplanes or helicopters, require fuel to lift off and stay in the air. But a vacuum balloon uses the difference in density between the vacuum and the surrounding air to float. This means it doesn't need an energy source to stay afloat, which could make it a more sustainable and environmentally friendly option for flight. Additionally, the concept of vacuum balloons could also challenge and expand our understanding of the limits of buoyancy and pressure in flight. It could push us to invent new materials capable of withstanding high-pressure differences, or to come up with innovative designs to make vacuum balloons a reality. However, while the implications of the vacuum balloon concept are exciting, it's important to remember that we're still in the realm of theory here. There are still many challenges and limitations to be overcome, and we'll get into those next. But for now, let's just bask in the potential of vacuum. They could truly change the way we fly. If only it were that simple. Now, let's get into the potential applications and implications of vacuum balloons in various fields. This is where things get really interesting, because the concept of vacuum balloons could extend far beyond just changing the way we fly. Firstly, let's consider the field of transportation. Vacuum balloons could open up a whole new dimension of air travel. We could potentially have airships or balloons capable of carrying heavy payloads across long distances, all without the need for fuel. This could revolutionize logistics, tourism, and even personal travel. Imagine taking a leisurely trip across the country in a floating balloon, enjoying the view from up high. Sounds pretty amazing, doesn't it? Next, let's talk about exploration. Vacuum balloons could potentially reach higher altitudes than traditional helium or hot air balloons. This could be a game changer for atmospheric research, weather prediction, and even space exploration. We could send vacuum balloons to the edge of space to collect data or take images, all without the need for expensive and energy-intensive rockets. And let's not forget about the potential environmental implications. Because vacuum balloons don't require fuel to stay afloat, they could be a much more sustainable and eco-friendly form of transportation compared to airplanes or helicopters. This could help reduce our carbon footprint and contribute to combating climate change. However, it's important to remember that these are potential applications. The concept of vacuum balloons is still largely theoretical, and there are many challenges to overcome before they can become a reality. But just thinking about the possibilities is exciting, isn't it? It's like a glimpse into a future where we've truly mastered the power of nothingness. But, as always, turning theory into practice is easier said than done. Now, let's tackle the elephant in the room, the challenges and limitations faced in the practical realization of the vacuum balloon concept. As fascinating as this concept is, it's not without its hurdles. First and foremost, let's talk about the issue of pressure. Remember how we discussed that the external air pressure could cause a vacuum balloon to collapse in on itself? Well, that's a significant challenge right there. To make a vacuum balloon, we would need a material that's strong enough to withstand the external pressure, but also light enough to float. And as of now, we don't have a material that fits the bill.
Another challenge is maintaining the vacuum inside the balloon.
Even the tiniest leak could let air in and ruin the vacuum. And even if we could create a perfect seal, the material of the balloon would need to be impermeable. That is, not even the smallest air molecules could pass through. Then there's the issue of control. With traditional balloons, we can control the altitude by releasing gas or heating the air inside. But with a vacuum balloon, once it's up, we don't have a clear method to bring it down or control its altitude. Lastly, there's the challenge of safety. Let's say we figure out a way to build a vacuum balloon. What happens if it bursts or crashes? The sudden rush of air into the vacuum could cause a powerful implosion. This poses significant safety risks that would need to be addressed. So, while the concept of vacuum balloons is intriguing and holds a lot of potential, making it a reality is a formidable task. But hey, who knows what the future holds? After all, every great invention started as a crazy idea, right? So, let's keep dreaming, keep questioning, and who knows, one day we might just unleash the power of nothingness